Hello guys, welcome back to the Aime problem solution video. Today we have yet another problem here, and as always, let's first start off by reading the question. So, suppose that x, y, and z are complex numbers such that x times y is going to equal to negative 80 minus 320i, yz is going to equal to 60, and zx is going to equal to negative 96 plus 24i, where I is going to equal to square root negative 1. Then there are real numbers a and b such that x plus y plus c is going to equal to a plus bi. Now we need to find a squared plus b squared. Now let's first start off by multiplying xy, yz, and zx. So write this down here. Now xy multiplied by yz multiplied by zx is going to equal to xyz squared. Now, because we know what each of these are actually equal to, it's going to be equal to negative 80 minus 220i multiplied by 60 multiplied by negative 96 plus 24i. And now let's divide this by yz, as yz is the only sort of product that we have here that does not contain a imaginary part. So xyz squared over yz squared should leave us with x squared. So what is x squared going to be equal to? Well, it's this big strand of numbers divided by 60 squared. So I'll write this out really quickly. It's negative 80 minus 320i multiplied by 60 multiplied by negative 96 plus 24i divided by 60 squared. And now since both the top and bottom part of this fraction both contain 60, we can just cancel them out really quickly and make your solving a little bit easier. Now expanding this, we get this is going to be a big number here, 15,360 plus 28,800i divided by 60. And further simplifying this, we get 256 plus 480i. Which means that we have x squared which means that we know that x squared is going to be equal to 256 plus 480i. However, x squared is going, and all of these numbers actually are going to be written in the form of a plus bi, which means that right here, we can see that since we know that this is going to be x squared, this is also going to be equal to a plus bi squared, which is going to further be simplified into a squared minus b squared plus 2abi. And now similarly to these, you can see the comparison. We have a real part and a real part here, and an imaginary part and an imaginary part here, which means that we can write out two equations. These being a squared minus b squared has to equal to 256, and 2ab has to equal to 480. Now, I'm going to skip past this again, as this is relatively simple. However, after you solve this, there are two possible solutions that you can get. You have a equals 20 and b equals 20. Not b equals 20, sorry, b equals 12. Or the other option, which is that a equals negative 20 and b equals negative 20. So basically, one is all positive and one is all negative. Now, I'd like to point out the fact that here, for the final answer, all of these choices will give the same answer. So for now, I'll just go with the first one, which is this one. And later on, if you really want to, you can go back and check all your answers with the second one. Now, since we have a equals 20 and b equals 12, we can see that x is going to be equal to 20 plus 12i. So now we need to solve for y and z. And luckily, since we know what x, y, and zx is going to equal to, we just need to divide them by 20 plus 12i and conjugate. So let's first look at y. Now y is going to equal to negative 80 minus 320i divided by 20 plus 12i. Now let's just conjugate this really quickly. So for this we should remove the common factor from both sides, which is going to be 4. So we get negative 20 minus 80i divided by 5 plus 3i, which is a lot more manageable. Now, how do you conjugate this? Well, it's pretty simple, actually. We're going to multiply both sides of this by 5 minus 3i. So we get negative 20 minus 80i on top, multiplied by 5 minus 3i, divided by 5 plus 3i multiplied by 5 minus 3i. And the reason why we do this is because this means that the bottom will have to be a real number. And after solving this, you should get minus 340 minus 360i. So not 360, 3 minus 340i as well. Over 34. Which results in y being equal to our final number, negative 10 minus 10i. Now, you'll use the same premise with the z. So, z is going to equal to negative 96 plus 24i divided by 20 plus 12i. And the same concept here is that you just remove 4, which is a common factor, and after that you multiply it by 5 minus 3i to conjugate it, and after that you solve. Now, to save time here, obviously, I'm not going to be doing that same process, this whole process again, so I'll just write out the answer, negative 3 plus 3i. This means that x plus y plus z is going to be equal to 20 minus 10 minus 3 plus 12i minus 10i minus I plus 3i, which is going to be equal to 7 plus 5i. This means that the final answer has to be 7 squared plus 5 squared, or 74. And going back to before, as you can see here, 7 squared plus 5 squared so equal to 74. And if we do use the other option, which is x is going to equal to negative 20 plus negative 12i, it'll just be negative 7 squared plus negative 5 squared, which is still going to be 74. Which means that the answer to this problem has to be 74. So thank you guys for listening. If you have any other way to solve this problem, please let me know down below in the comments, and thank you guys for listening. Bye.